We're going to solve what's called an initial value problem because we have a differential equation and we have an initial value, which means we're actually going to be able to solve for the constant. So first thing we need to do is set this up so we can use separation by variables. So we'll move this to the other side. So we get dp dt equals negative tp squared. Now we'll separate our variables. The p needs to come down here. The dt needs to come up here. So we get dp over p squared equals negative t dt. And now we're going to do the antiderivative of both sides. The right-hand side's nice and simple. It's negative t squared over 2 plus, we'll call it c for now. This one is actually not bad either, but one thing that happens quite often on this one is a lot of people will do ln of p squared because we have so many solutions with differential equations that involve a natural log. But actually, if we think about what's going to happen here, this is actually a power rule. This is p to the negative 2. So this becomes negative p to the negative 1. So we have negative 1 over p equals negative t squared over 2 plus c. And we do have the initial condition that p of 1 equals 1. We can solve first for p, or we can do our initial condition and then solve for p. It really doesn't matter. One thing we are going to want to do is get rid of the negative. So let's multiply everything by a negative. We get 1 over p equals t squared over 2. And we can either change this to a minus c, or we can absorb the constant. We'll call this c, and we'll just call that guy c1 just to note that they're not exactly the same. So if we want, we could go ahead and solve for c now, or we can continue to solve for p. Again, that part doesn't matter, but I'd say let's go ahead and get our c now. It's because our numbers are so easy. So 1 over 1 equals 1 over 2 plus c. So 1 equals a half plus c. We get that c equals 1/2. So putting that back into our original, we get 1 over p equals t squared over 2 plus 1 over 2. So we can see that that's going to be t squared plus 1 over 2. And this actually makes ours very easy to solve because now we can actually just flip both sides. And we get p equals 2 over t squared plus 1. As long as you do everything correctly, it doesn't matter when you insert your initial condition, but a lot of times you'll find it easier to put in early on, right after you've solved your differential equation, but before you've solved for your variable. It might make things a little easier.